Conrad. I run the Ethereum meetup group in Chicago. So we already have the next two meetups planned. So the first Thursday of September is going to be a talk on cryptography for cryptocurrency. So you know, a lot of people who are into cryptocurrency maybe don't know so much about the crypto part of it. So we'll try to have kind of a medium range level difficulty talk on kind of going over all the essential concepts and some of the math. And then the month after that, in October, we're going to have two parts of the presentation. The first part will be cryptocurrency taxes. So we have Andrew Gordon from Gordon Law Group is going to be talking about, he's a tax attorney, talking about how the taxes revolve around currency exchanges and those kinds of things. And then also, as part of that, we're in October, we're going to have lightning talks. So if anyone, if anyone wants to do a full talk, like an hour, you know, get in touch with me and we'll see if we can get it scheduled if it's something Ethereum related. But if you only want to do a 5 to 10 minute talk, October would be a good opportunity because we're going to do a series of lightning talks where you send the slides to me and we'll have a single slide deck so we can go through them quickly. And I'll send out a meetup message on that sometime soon. So this talk today is by Sean Von Kuller, and it's on the marketplace for the Ethereum name system. So currently, Ethereum is a blockchain like Bitcoin with one extra very important feature, which is that you can have smart contracts that can interact with the currency that's on the blockchain. But this is kind of only part of a bigger vision. The bigger vision is to essentially come up with sort of a Web3 concept where you can build entire applications with rich resources, with complex behavior and communication abilities, and build them all in a decentralized way on top of the Ethereum blockchain. And so the first part of that vision is that you need some way of having unique names assigned to people. So just like we have .com names, Ethereum has this concept of .eth names. And there's one name service that was launched in April of this year, which is the Ethereum name service that was developed by the Ethereum Foundation, where you can currently register an arbitrary Ethereum name. And currently it's limited to names of 7 characters or more. Hello? Oh, awesome. But all you can do there is register it. There's no ability to exchange names with other people for money, and there's no way to sort of set up any kind of auctions, secondary auctions for names. This opens up a great opportunity for anybody who wants to create a marketplace for exchanging domain names using smart contracts so that you can atomically exchange names and currency for payment. And so that's what the demo is going to be and the presentation is going to be on today. So, and let me thank, again, WeWork, Lexi, and Jennifer for arranging this space for us. It's really great.
Thanks for the introduction, Conrad. Hello, everyone. Thank you all for coming out tonight. It's our first time in the Chicago Blockchain Center. It's pretty exciting. Really excited to be here. A little bit about myself. As Conrad said, my name is Shane Van Koller, and I work at a company called Productive Edge. I'm a systems architect over there, and yeah, basically here tonight to demo an application that I've been working on for the last couple of months. Yeah, so I'm just going to give it to show everybody. So before I get started, can I get a quick show of hands? Who has heard of ENS or knows what it is? Okay, cool. So for those of you who don't know, I'm going to try and go through a very quick explanation of what it is, how it works, how it's built. and hopefully give you a bit of a better context as to where my application is coming from. So ENS is the Ethereum name service, and its basic function is to map human readable names to Ethereum addresses. As Conrad said earlier, it's 100% powered by smart contracts, which gives it the ability to take advantage of the benefits of being decentralized, stable, and totally transparent. So the easiest way to think about ENS is to compare it to what DNS does for the traditional internet today. So what DNS does is it'll take a human readable name that you and I understand, like etherscan.io or google.com. It's easy to put into the address bar, easy to remember, and it's going to map those to an IP address, which the computers need to understand in order to communicate with each other. So ENS basically does the same thing. It takes a name like shanebankcollar.eth and maps that to an Ethereum address. So if we just look at that example I just gave, shanebankcollar.eth, all ENS names currently end with ETH, and that is currently known as the top-level domain. So if we take a bit of a deeper dive into the architecture of ENS and how everything is put together, it consists of two main components. The registry, which is basically the heart of ENS. So there is only one contract that controls the registry. And the main purpose of the registry is to maintain a list of all the domains and subdomains that it knows about. It also stores 3 additional pieces of information about each of the domains and subdomains, and those are the owner of the domain, the resolver of the domain, and the time to live for all the records underneath that domain. So as the owner of a name, you have got certain privileges to manage your name, such as you can update the resolver of the domain as well as the TTL attribute. Or what you can also do is transfer ownership of your name to a different address. So there's no, the only cost involved in that transfer is the gas cost. There's no actual money that changes hands when you do that transfer. So another interesting thing about the owner of a name is that it can either be owned by a user address, so any normal kind of wallet address, or it can be owned by a contract, a smart contract. So when it's owned by a smart contract, it is known as a registrar. So the top-level domain that we saw in the previous slide, the top-level domain is .eth. That top-level domain is owned by a contract and therefore is a registrar. And what the registrar does is it basically just defines the rules by which the subdomains are distributed. In this case, on the mainnet, the ETH registrar defines how the subdomains get distributed, and this is by means of a blind auction. I'll get to the details of how that works in a second. But if we compare that to the testnet, there is an additional top-level domain on the testnet, and that is .test. So the address would be shanebankcollar.test. And the registrar for the test name defines a different algorithm for distributing those names. So instead of going through a blind auction, the one on test uses a first-in, first-served algorithm to distribute the names. So the important thing to take away from this is that ENS names can be owned by contracts. If they are owned by contracts, that contract defines how the subdomains are then distributed. Then the second part the second component of ENS are the resolvers. So now there can be many resolvers. It's not just limited to one. So the main responsibility of a resolver is to translate the name itself into an address. So there are currently a few public resolvers that you can use, so you don't have to implement your own one. The only reason you would implement your own one is if you have some complex requirements, but if all you want to do is map your Ethereum name to an address or a contract or a swarm hash, then this public resolver that is available should suit your needs just fine. So there's no need to kind of go and create your own, but you can if you want to. So these resolvers can also store additional metadata about a name. I mentioned the swarm hash, so if you want to link your ETH name to something that you deploy to Swarm, the resolver will be able to store that information for you. If your ENS name points to a contract, you can also store the API information within that contract, as well as any kind of who is information for in case that account is owned by a person. So now that we kind of know how ENS is kind of put together, how do I go about getting a name? So names are currently required to be 7 characters or longer. The 6 characters and less will be released once the registry has been finalized. That's in a kind of a phase of testing. The names that are available, they are issued based on a blind auction, also known as a victory auction, and this auction proceeds in 3 stages. So the first stage is the auction is opened when a bid is placed on a name, and what this does is it kicks off a 3-day timer in which time anyone else can make a bid on that name. Then the reason it's called a blind auction is because the details of your bid are completely hidden. So the amount that you bid, the name that you bid on, no one knows that. It's completely anonymous. So after this bidding phase is over, a 2-day reveal period begins. At this time, no more bids will be accepted in this reveal phase. So during this reveal phase, all of the bids that have been placed need to be revealed. If you have made a bid on a name but do not reveal your bid within this 2-day period, you will lose your entire amount that you bid on that name. So that's just a word of caution. Then if your bid is not the highest, so if someone comes in with a bid higher than yours, your entire bid is returned to you minus a 0.5% fee, which is basically just burned. Okay? Then once that 2-day period is over, the winner is basically the person with the highest reveal bid. But they only pay the amount of the second highest bid. Okay? That's quite important to know. Then another pretty interesting thing about this is that the ether that you pay for your ENS name doesn't actually go to anyone. What happens with it is it basically gets bonded to that name for a period of 1 year. After that year period is up, you can, if you so choose, release the name back into the pool of available names, and all the ether that you have bonded to that name gets returned to you. So that's pretty cool that no one person gets paid for these names, unlike when you go and buy a .com or something. You kind of get all your money back, which is quite nice. So what now? You've got your ENS name. Maybe you don't need it anymore. You kind of bought it, and now things have happened, and you kind of regret buying it, and you just don't want it anymore. So you could wait the year to that year period that I mentioned. You could wait that time to release that name back into the pool and get all your ether back. Or on the other hand, say you really wanted a name, but you missed out on the auction period for some unknown reason, and now someone else snapped up your name, and now you don't have it. So you need to, you want to go buy this name, but there's no way to do that. So enter the marketplace. So the marketplace is a platform that allows you to sell that name that you might not want anymore, or it allows you to go and search for a name that you really wanted, check that it's for sale, and make a purchase if that's what you want to do. All right, so with that, I'm going to jump straight into the demo. I do just want to say that I'm presenting this over GoToMeeting, so it might be a little bit laggy, so please bear with me if it is. I'm going to take this. Okay, so the first thing that you're going to notice here is that I'm going to be doing the majority of my demo through the Mist browser. The new version of Mist fully supports ENS names. And another cool feature feature that it has is it's got a built-in Swarm node. So what I've gone and done is deploy my application to Swarm and pointed my ENS address to that Swarm hash so I can type in the MKT.place in my Mist browser and get served up my application. Yay, Web 3.0. So the first thing you'll notice here is that I don't have any accounts connected to this Mist instance. So I'm going to go ahead and do that quickly. Just going to authorize one of my accounts that I've got in Mist. Okay, and then you'll see up here on the menu bar, it just tells you who the account that you've signed in with, as well as the balance of that account. So, so the landing page that you see here is obviously the first page that you see when you open up the application. And what it shows you is a listing of all the names that are currently on the market and for sale. The sale address, the asking price, and then you will see there's an action column over here which basically just changes based on your ownership of the name that is for sale. So the names in orange here are the ones that say cancel and finalize. The account that I've logged in with owns those names. So it's just a shortcut to be able to either cancel or finalize a sale. I'll get to what the finalize and pending actually, I'll get to what that means in a second. But basically this is just a very good way, if you know what you're looking for, you can go straight to here and buy your name. This little data grid that I've got here also allows you to search within this data grid. So if you search there to find it pretty quickly. Then there's two other tabs at the top here. One is My Purchases, which is obviously a list of all the purchases that I've made with this account, just listed over there. So you'll see on the right-hand side here, I've left space for some advertising. I'm not going to say too much about that right now, but keep it in mind because I'm going to come back to it at the end of the presentation. So again, the same data grid that was on the main page. You can search through it, you can order, and again, basically just shows you the list of purchases that I have made with this account. And then the last tab over here is the My Sales. So these are all the sales that I've made. And people bought from me. So interesting to note here that both these My Sales and My Purchases tabs are listening to events being fired from my Solidity contract. When I go through the code in a second, I'll show you exactly how that's all put together, but this is listening directly for new events coming from that code. All right, so let's say I want to sell one of my names, okay? So what I can do is I can search for the name up at the top here. And remember earlier I said that the names have to be longer than 7 characters, so the search doesn't start until you get to 7 characters. So I've searched for this name. It tells me what the name is, what the status of that name is, so this name's currently owned, and it gives me the option to sell. Because I'm the owner, I'm obviously the only one who can sell this. If we take a look at a name that's owned by someone else, for example, because I don't own this name, I can't really do anything with this, but it does give you information about who does own it, what the resolver is, how much bonded ether is there, creation date, and the previous owners. So there's a whole bunch of information that this screen allows you to kind of see that you don't get on that overview screen on the landing page. So back to this name over here. Just to point out here, because I'm the owner of the name, as I mentioned in my earlier slides, I'm able to update the resolver as well as the time to live attributes because I'm the owner of that account. I'm not going to do that right now. I'll show you that in a second. But just know that because I'm the owner, I do have the ability to change those fields. So I'm going to go ahead and list this name for sale. So I'm going to hit the sell button, and it's going to come up with an asking price text box. So that's how much I want to receive for this name. Underneath that is the amount of bonded ether that is currently in this name. So how this works is to ensure that you get all of the money that you originally put into the name, to ensure that you get all of that back. That always gets added to the asking price that you put in here. So if I put in an asking price of 3 ether, it's going to be 3.0 because 0.01 was the amount of bonded ether originally in that name. Okay. So I'm going to go ahead and click sell. What's going to happen now is it's going to ask me to sign the transaction because this is going to be submitted to the blockchain. And it's going to list this name for sale within my contract so that it can display it on the main page. The sell is quite an interesting thing, and again, I'll explain all the details of it when I get into the code. But what happens here is that it's a two-step process. So actually, let me get this started off because it's going to take a while to mine the transaction. So I'm just busy. So what's happening now is there are two steps to the selling process. The first step is registering the name with my contract. So you tell my contract, I want to sell this name. So that's the first transaction that's happening. So that while that's been going on, let me talk about the second step, which is transferring the domain ownership. So what needs to happen here is you as the owner of the name need to transfer the ownership of that name to my contract. And as I said earlier, I'll explain exactly why when I go through the code. But I think this is something that is maybe a little bit foreign to people, especially if you're used to the traditional internet. Trusting that an application is going to do what it says it does. People aren't very used to that idea. But that really is the power of the blockchain technology is that before I even click sell, I can go to this contract, have a look to see what's going to happen if I transfer ownership to it. And if I click cancel, what's going to happen? I can confirm that if I do click cancel, it's going to be returned back to me. So you can trust this contract 100%. Sorry, just checking that's working. Which is a pretty cool concept, and as I said, I think something that doesn't happen on the traditional internet because you don't really have any insight into like the code that other people are writing. So that transaction eventually got mined. So now it's asking for the second part of this, which is the transfer of ownership. I'm going to authorize that. So this second part is just transferring ownership. So we'll wait. Hopefully, it won't take too long to mine that. So basically, what's happening in the background here is that I've signed the transaction. It came from idea. It's then submitted into the blockchain, and now this pending bit is it's basically just waiting for that transaction to get mined, which can take variable length of time depending on how much gas you provide, and also depending if you're on the test net, which I am, Boston, take a little bit of time. So,
and the reason there's two steps is because there's two different contracts involved, and they both need to know that you're the signatory. Is that why?
Correct. Yeah. So basically, how that works is the transfer method that's provided by the EMS contract. There's a method on there that says owner only. There's a modifier, so that means that only the owner can transfer ownership. So what happens here is if I don't do this transfer of ownership initially, when the buyer wants to buy the name, it's going to be my contract calling the transfer method, and my contract doesn't own the name, so it's going to fail. I'll definitely explain that in a little bit more detail when I get to the code. Okay, so I've now successfully listed this name for sale, so I can go ahead and close this box. You can see on this page has been updated. I'm not going to cancel the button because it's for sale. I've also lost the ability to edit these attributes over here, and that's purely because now the contract is the owner of this address. I can't edit any of those. So if I now go back to listing page, I'll be able to see that the name that I've just put up for sale is listed on this table over here. All right. So now, let's say I feel like buying a name. Let's go and buy a name. So again, I can either do it from this page over here directly, or I can go and search for the name and get a little bit more details about it. So let's say before I purchase this name, I want to see how much quantity there is in that name. So I'm going to go ahead and search for that name, and we can see, here's the bonded ether, there's 0.1 bonded ether. For whatever reason, I wanted to know that. Great. The selling price is 1.01 ether. That's fine. I've got 10 ether in my account. I'm going to go ahead and purchase that name. Again, sending a transaction to the blockchain. So what's nice about this is that once you put your name up for sale as a seller, that's the last thing you need to do, because you've done those 2 steps in the beginning by listing it for sale and transferring the name to my contract. That's the last thing you need to do as the seller. So when a buyer comes along and they click on buy, my contract is going to handle the transfer of the ether as well as the transfer of ownership of that name. So as the seller, right now, they've just got 1.01 ether in their account because the sale has just taken place. So as soon as the sale takes place, this page updates, and I've now got the ability to sell this name because now I own it. And again, I can now update any of these attributes on this page over here. So let's say we're looking for, I think I showed you the, if no one owns the name, or if you don't own the name and it's not for sale, this is the status that you see. But let's say we're looking for a name that is still available, that no one owns it. So we can maybe just type in Forza Ferrari. So this name is available, no one owns it, and it is available, and the auction hasn't started yet. So basically, you could go and bid on this name as much as you want, start the auction, and go through that blind auction process. If you click on this, it will take you out to the registrar.ems.domains, warning me that I'm on the Robster network, and I can then go ahead and place my bid through this website. So it just kind of links out to that site. So I'm going to search for another name just so I can show you the updating of these attributes. So when I was talking about resolvers earlier, there is, I spoke about a public resolver. So this resolver, in the case that your requirements are very simple, and all you want is your name to resolve to your address. So let's go ahead and do that. So I own this name, so I'm going to set my resolver. Because it's a public resolver, the address is pretty much always the same. So I've got a little default button here, so just default to that public resolver. If you don't trust my idea for whatever reason, you can go and check that address is actually the public resolver. You can copy and paste it into this field directly. This is just a little bit of a shortcut. I'm going to go ahead and set that as my resolver. And while we wait for that transaction to get mined, what you're going to see next are 2 additional fields that I can edit. One's going to be resolver address, and the other one's going to be resolver content. The resolver address is really if you just want to point your name to a contract address or to a wallet address or to anything like that. The address content is if you've got something deployed to Swarm or Swarm hash, you can enter that in there so that there's no reason to grab or to present that data from Swarm. What's really cool about this too is that one ENS name, you can specify both the address as well as the content. So what that means is that for this name here, I can specify that if you want to send me money, I can give you this McLaren.eth name, and you can send Ether to that account. But if I've also defined a swarm hash for the same name, if I then go to this McLaren.eth and put it into my Mist browser, it will then navigate to wherever that swarm hash or whatever's deployed at that swarm hash. So it's kind of like a dual purpose thing. So it's not just, if you've got an address linked to the name, it's not just for that, but you can kind of do multiple things with it, which is pretty cool. So just waiting for this to mine. Seems to be taking a while tonight for some reason. While we're waiting for that, actually, I've been talking non-stop. Are there any questions so far?
When you press the bid button on a domain that you don't have yet, you could probably directly in your app actually begin the bidding process, right?
Correct, yes. Because that's the registrar for that is a contract, I can even interact with that from my app directly. So, yes. Yeah.
How many confirmations do you wait for?
I think this one is, I think it's about 5 or 6, I think. I'm not 100% sure. Again, I'll show you how I actually wait for that confirmation in code. So now that's finally updated. The resolves to address and resolves to content are available for us to edit. So if you want to resolve to address, as I said earlier, you can just update here or to a swarm hash, you just update it. All right. So, yeah. I'm sorry. Yeah.
Is there a minimum amount either to start a bid or?
To start a bid, yes, there is. It's the minimum is 0.01. But for my application, obviously that's going to be already taken care of. So for you to sell it, you can sell it for 0.01. That's going to be the price. Okay. So one thing I haven't explained yet is this finalize and pending button over here. So what you might have noticed when with that initial sale process, there were those 2 transactions. So if I accepted the first transaction, which lists my name for sale in my contract, and then cancel the next one, so cancel the transfer of the ownership of the name, what happens then, which is that name will go into a pending state. So this name Formula1.eth, that's exactly what happened in this case. Because I'm not the owner of that account, all I see in my listing page is that it's pending. So I'm waiting for the owner of it to finalize it, and finalize it basically just transfer ownership to my contract. I've done the same for this casinos.eth over here, and this one I do own. So what happens here is that I've got the ability now to either finalize the contract, in other words, transfer the ownership, or I can just cancel the sale completely. So if I go to more detailed name, I've got the options to finalize or cancel it directly from here. So that's just kind of where the pending and finalize buttons come in. All right. So that's pretty much the main functionality of the application. One little extra thing that I have added is this transaction history button at the top here. So what this does is this just keeps track of all of the transactions that you have submitted to the blockchain. This is all stored locally, client-side in a cookie, so it's not persisted across anything. So if you clear cookies or depending on how you got things set up, it's not going to persist across sessions. But because it doesn't have anything to do with functionality of that, it's really just a useful kind of info thing to have that doesn't really matter. So this is a transaction hash for these transactions, and then basically the action which you perform within my site, as well as the gas cost for each transaction. So the first thing we did was we registered a name for sale. The 2 transactions that got processed there was registering for sale and transfer the ownership. So I can then go and actually click on this. It's going to hop out to Etherscan, and you can see exactly what happened in that transaction. You can see what contract it went to and all that information that Etherscan provides you. So this block explorer, for those of you who don't know, is really just a place where you can give it a transaction hash, and go and see the details of what happened with that particular transaction. If there was any Ether transfer, it will show up in here. It also shows you the event log, so any events that were fired also get shown here. Which reminds me, I didn't go back to here. So in my purchases, when I made that purchase of Springbox.eth, it populated in this purchases tab, and you'll notice I didn't refresh the page at all. That's because it's listening to the events dynamically, and will populate as soon as it gets a new name. I've been doing most of my demo in, I've been doing all of the demo up to this point in this. It does work in Chrome as well. So if I hop over to Chrome, you'll see exactly the same application. The way it interfaces, the way Chrome interfaces with my application is through the MetaMask plugin. So you'll see I'm logged in with a different account here, just to show the difference. And the way the transaction gets signed here is that it's MetaMask. MetaMask is used to kind of sign all the transactions that come from the Chrome browser. All right. So that concludes the demo. So what I want to do next is have a look at the code and show you exactly how all of this is put together and how it all works in the back. Before I get there, any further questions on the app? There will be a question and answer at the end. So if you want to get your questions now, yeah.
Yes. The bonded F, is that only set during the auction process, or can you increase that when you purchase the market?
It's only set at the time that you do the bid. I think you can actually add to it if you want to. There is no real reason that you would want to do that though, because it doesn't add any value to your name other than getting it all back.
All right. Can I ask a follow-up question on the auction? Does the auction start on first bid, and then what's the timeline after a first bid?
So the auction does start on first bid. So if you're the first person to bid on a name, what actually happens is you open the auction as well as place your bid. And at that point, the 3-day timer starts. So whenever you submitted that bid, 3 days from that time, that is when the auction will end and the reveal phase will start, where everyone has to reveal the names. And then 2 days after that, the board is kind of determined.
Cool. Thank you.
Cool. Yeah.
Can you speak a little bit about the maturity of the ENS at this stage in terms of like how many registrations we have per month, how that's increasing some of the trends, just so for somebody who's kind of not been diving into it that much, like to kind of get a sense of what the transaction volume is?
Yeah. So currently all names that they have released have been, they've released all the names that they were going to. I think, I can actually pull up the website, but there has been a massive volume. I think in total there's over 3.5 million Ether that's been spent on ENS names at this stage. So that, yeah, it's a pretty big market at this stage, and that's only for names over 7 characters and over. So it's only just going to get bigger once they release the short ones. Cool. All right. So let's jump back into it. Okay. So we're going to go through the contract code first. There are a couple of things I just want to call out before I actually jump into the code. And this is something that the kind of I'm just busy chatting about now. So there are a couple of variables that are available to you within Solidity just straight away. One of them is message.sender and the other one is transaction.origin. And the use of either or is pretty important. So to illustrate the difference, let's say we're given a call chain of contract A equals contract B equals contract C, and contract C equals contract D. So if we take a look at the message.sender within contract D, it's going to be, the value of message.sender is going to be C. So that means that C was the one that called D. If, however, we look at the transaction.origin inside D, that's going to be, the value of that is going to be A, because A is where the transaction originated from. So this sounds really useful, but it's actually really, really dangerous. And the reason for this is because if I in my contract set a modifier to say that only the owner can withdraw funds from my contract, and my modifier checks the transaction.origin instead of message.sender, what's going to happen is me as a malicious contract developer, let's call me B, I'm going to get you as A, in this example, to interact with my contract somehow through some phishing scam. You're going to send a transaction to me, to my contract, and because I know that contract C checks the owner as transaction.origin, I know that I can call that with my contract without it knowing that I'm not the owner. So in the case where A calls my malicious contract B as contract B, I'm then able to withdraw all the funds from contract C because contract C thinks that I'm the owner. So just from that, you can see that it's really dangerous to use transaction.origin. So it's actually been deprecated in Solidity as of, I think, the last version. So message.sender is definitely the one that you want to use, especially when checking for ownership of a contract. So, as I alluded to a little bit earlier, that's the exact reason why the sell process is a two-transaction process. Because only the owner of that, or the D behind the name, it checks the owner by doing message.sender. So in the case that my contract tries to make that transfer not being the owner, it's always going to fail. So that's why we have to do the transfer up in the beginning and for this process to work. So another just little important thing to note, that another variable that's available to you is message.value, and that's the value that's sent to the contract, and this is always in way. So just keep this in mind if you're doing contract development and you're doing any calculations with message.value, just keep that in mind. It's the way value. So if you specify one, thinking that it's going to be one ether, it's actually not. That's going to be one way, which is from the conversion down here. That's a really small amount of way. There are some keywords available in Solidity that allow you that you can do conversions quickly. So you can specify one ether, and the Solidity compiler will convert that directly for you into way. There's a pretty handy converter online that you can use over here, just for interest sake. So I'm going to jump up into the code quickly, and I'm using the Remix browser. This is a little bit bigger. So I'm just going to go through this pretty quickly. If there are any questions, please feel free to interrupt me and ask if you do have a question. So the first two things you see in the contract here are these abstract contracts. All this is here for is because I'm using the ENS and registrar contracts within my contract, so I'm making a call out to these two contracts. And the only way the Solidity compiler can compile successfully is if it knows something about the contracts that I'm calling. So that's why all I've done here is defined an abstract contract, and all it has is the functions that I'm calling from within my contract. So there's obviously being an abstract function, there's no implementation there. So this is purely so that the Solidity compiler can successfully compile. So that's for both the abstract ENS and the abstract registrar. Then going through my actual contract, I've got a struct here which holds all the listings of the names that are for sale, domain states, the owner of the contract, a couple of variables just for the total number of listings, active listings, and then these two abstract registrar, ENS and registrar variables so that I can interact with those contracts. A mapping that holds all the names. How this mapping works is the key for this mapping is the name of the name, and then that just maps to the the listing structure that I've got at the top here. I've got 3 events that fire at certain stages. There's a for sale event, a sold event, and a cancelled event, and you can listen to for those in the video, which I showed you a little bit earlier. But one modifier, this is to say that only the owner can do certain things or can only call certain functions. So this sets up the modifier. I'll show you where it's used in a sec. Then another kind of interesting thing is this line over here. This is basically, okay, so sorry, just one step back. Going into my constructor, one of the arguments, or two of the arguments for this constructor are the address of the ENS and registrar contracts themselves. And then what I do is I basically just instantiate a new abstract ENS with that address, and what that does is it basically then connects to that address and allows me to call the functions from that address. So you can see that over here is the registrar. I call the entries function and pass it some input, and it's going to return to me. So this over here might not be familiar to people who are used to kind of like traditional programming languages like Java. The multiple return values. In this case, this function returns 5 items. I'm only interested in the 4th, so I can just kind of specify lengths up to that point, and I'm only interested in the 1 return value that it does return. And then kind of use that to set the total selling price. If we head over to the buy function, you'll see there's a payable keyword in this function, which means that this function expects ether to be sent to it, and which is, if you're buying a name, you have to send the ether with the function call. So this payable just allows you to use the message value to know how much I sent to you. Then there are a couple of checks up in the front end to make sure that the input is correct, that the name is in the correct state, and that the owner of that name is currently the contract itself. That's just kind of normal safety checks up front. Then this being the buyer function, there's a couple of things that happen. So we transfer the ether that came in, we transfer that directly to the seller. And then we just require that transfer is completed, just to make sure if for whatever reason that transaction failed, this will make the whole block roll back so that the person who sent the ether can get their ether back. And then one of the last steps we do here is actually transfer the name into the buyer's name. Okay. And then just a couple other functions. There's the cancel listing, which also basically does some similar stuff. These internal functions here, I just wanted to call this out. I think we're all aware of the parity multi-sig wallet issue that happened a while ago, where the default access to a function in Solidity is public, which is different from most other languages. So if you forget to put in your access modifier there, it's going to default to public, which means that this function can be called by anyone and by any contract. But by specifying that it's internal means that only my contract can call this function. That doesn't mean though that you won't be able to see this function if you look at the code or anything like that. You'll be able to see exactly what it does, but you just won't be able to call it. So that internal keyword is pretty important, especially for things that you want to keep internal, and it's not default, which is the thing I wanted to call out there. All right. Any questions on the Solidity code? Yes.
On line 58, when you show the destructuring, how does it infer the type from the destructuring?
So the return type of this entries method defines what it's returning and what the types are. So if you look down here, and I return multiple values down here. So it actually specifies this function returns a string, an address, an int in that order, and it knows. So when you use it like that, it knows that is the
So entries is a Solidity like utility function then?
No, entries is a function on the registrar contract itself.
Okay, okay.
Yeah.
And then back up at the top, you go like, I think it's like the first line.
Yeah.
Why is that not an address type, the node there?
This node here.
Yeah.
So the node here is the ENS name itself. So it's not the owner of the name. It's the name itself.
Okay.
So what I didn't explain here is that the ENS names within Solidity and within the contract are not represented as strings. They're represented as a byte array.
And that's just a result of the ENS contract, how it operates?
Correct. Yeah. So if you ever want to kind of interact with these names, you need to hash the name itself. So shaman.eth, you need to hash that before you can call any of the contracts. And that's just the way that the ENS is designed to work internally. One of the reasons is because you can have arbitrary length names, and if you hash them, they'll always be 42 characters or whatever. And it also kind of gives some sort of anonymity to the names on
Where do you perform that hash in this contract?
I do not perform the hash in this contract at all because it can be an expensive operation that you're going to be paying gas for. So what you'd rather do is do that in DIA and just pass in the hash value to your contract so you don't have to pay the cost of that.
Do it on a client and then.
Correct. Yeah.
Cool.
Yeah.
Thank you.
All right. Any other questions on the contract code? Yes.
So I noticed you have an active listings array where you can delete items off
Yes.
by incrementing.
Yes.
Have you figured out like how many items you can support before you run out of gas?
I haven't, and that's one of the things that I need to figure out really, really quickly. And the reason I have to use an array is quite an interesting one, and I think I'd be happy to chat to you about that afterwards.
Yeah, offline.
Yeah, it's actually a really interesting problem that I think a lot of contracts are going to have, especially ones that need to list out any kind of array or anything. I think the biggest problem there is because Solidity won't allow you to return any array or any list of values. So if I've got an array, I can't return that array to my client side and iterate through that array, which is one of the limitations of Solidity at the moment, which makes this problem quite a problem actually.
Yeah, what I use in such cases, I would have a constant function that returns number of elements in the array.
Yeah.
That's how we get the length.
Yeah, and that's exactly what I've done here. So yeah, and that's kind of a workaround. The one thing that I will say about the arrays though is because Solidity is still in its infancy, things that you take for granted using Java or .NET is array cleanup. So if you remove an element from an array in Java or .NET, it fills up that hole, so there's no hole in your array. So you've got elements like 1, 2, and 3. If you remove 2 in Java or .NET, your array length is going to be 2 because you removed that one, and that hole is going to be filled. In Solidity, though, that doesn't happen. So you actually have to manually go and fix your array so that you don't have holes all over the place. And that's kind of the comments question that kind of alluded to that. So we can definitely chat about that offline. So it does make for some pretty interesting problems and solutions to those problems. Okay. So looking now at the client side, the actual DApp itself, a couple of interesting things from the DApp. The way the DApp interacts with the blockchain is by a JavaScript library called Web3, and all interaction from your HTML and your JavaScript happen through this Web3 library. Important thing to note here is that all of the transactions that happen through Web3 are all asynchronous. And the reason for this is because, as you saw earlier when I was going through the demo, those transactions can take some time to be mined. So you don't want your UI to lock up and just be waiting for this transaction. So the way around that is to make all of these function calls asynchronous. So you call them, provide a callback or a promise or whatever you want to use in your JavaScript, and then it will then return to that once it's done. So that's quite important to note, especially when using the Mist browser. Mist does not at all support synchronous methods anymore. So if you've got any synchronous call through Web3 to the blockchain, it's going to throw a runtime error and your app will break. The other part I want to just highlight here is that we obviously want to interact with the smart contracts that we've just written from our front end. So I just want to walk you through and just kind of show you what we need to make that happen. So one thing that we do definitely need is obviously the address of where my contract is deployed. And we also need the API, which is the application binary interface, very similar to an API in normal programming terms. API is just the one used for the project contracts. So, right here again, and into the code. So, just showing you, can everyone see that okay? So at the top here, I've just defined my contract addresses, my contract APIs. So this is the address that my contract is currently deployed to, and then this long string here is my API, pretty long string, and that basically defines all the methods and return types that and function inputs that my contract that you can do on the contract. And then how you call that is you basically make a call to Web3. This line over here. You make a call to Web3. There's a contract method. You give it the API and you tell it which address that contract is at, and that sets up the connection to that contract. So now I can use this MyEscrow variable throughout my code and be able to access all the methods that I've defined in my contract. So if we take a look at this method over here, I make a call using this MyEscrow, which I instantiated in the common JavaScript class. My contract's got a get non-active listings function on it, which I can then just call by saying that object dot function name. It doesn't take any parameters, so I think if we just go back here quickly, so this is the function that I'm calling. It doesn't take any parameters, but returns an int. Go back to here. So no parameters as an input. This is just a callback because it's asynchronous. So this is what's going to get executed once this function gets called. And then we can use the return type, which comes back as the second parameter in your callback. So you can use that wherever you need to kind of do whatever you need. And this function here basically just populates that listing page that was on the landing page. So that's how we interact with contracts. Then I said I'd go through and show you how I wait for a transaction to be mined. And again, it's a call to Web3. There's a get transaction receipt method. You give it the transaction hash, and then the callback. So basically what you're doing is you make a call to this transaction receipt. If there is a receipt, it means your transaction has been mined. If there's no receipt, it means it hasn't yet been confirmed. So inside this function, I just basically set a timeout. So if the result is null, in other words, there is no receipt number, then I just set a timeout of 5 seconds and call the same function again until the result does have a value, which means that it has been confirmed. And then I go ahead and set some cookie data and call the callback that I defined further in my code. So I hope that answers your question about how to wait for the transactions to be mined. Another interesting thing from that Web3 provides, I think it's in. So what I wanted to show you quickly also was how we watch for events that get fired by a contract. So again, we just use the contract variable that we created right at the beginning. Then we just specify the event name, pass it some parameters. You can and say where you want to start watching from, where you want to watch to. This instance here actually doesn't get, so this just gets all of the sold events from this block number to the latest. Once it's got all of those, then call back over here, pulls back to this and then populates the table. And then if you want to watch for new events, there's a watch function, which then just basically watches for new events. As soon as a new event's fired, calls the callback and adds it in this case to my data table. So that's pretty interesting. Then the last thing I wanted to show you was, remember I said that the contracts all work, the message.value is always in the way. So to send and receive Ether amounts from your contract, Web3 provides a from-way and to-way function. So when you call when I call my contract to get the amount that the name is listed for, that gets returned to me in way. But Web3 does provide a method where I can convert that from way into, in this case, I'm converting it into Ether. So that's why on all of my data tables, the value that you see is in Ether, not in way. So Web3 does provide functionality to do that, which makes life a little bit easier. Any questions on this part of the code? Yep.
Is this open source? Can I take a look at this?
It is not open source just yet, but it probably will be once I deploy it to the public internet.
What kind of JavaScript frameworks are you using? I noticed it looks like there's jQuery in there.
Yeah,
Is there anything else?
No, just pure JavaScript jQuery for now. I was thinking about using something like Angular or something like that, but just stuck with the plain. And then for the front end, it's just Bootstrap. Any other questions? Alrighty. Okay, so now there's, I haven't completely finished my app. There's always more to be done. I think all the developers in the room will agree with me there. Your app is never finished. So I've got a roadmap of things that I want to still add to my application. Top of the list is solicitations and bidding on already owned names. So currently if somebody owns a name and it's not for sale, there's no way for you to buy that name or to even get hold of the person who owns the name. Very difficult. So I'm going to add in functionality that will allow you to solicit that name from the owner. What's going to make this work really well is that I can add notifications as well. I'm planning to use the Whisper protocol of Ethereum to do this. So if I solicit a name from you, you'll get a notification somewhere to say someone is interested in your name. Otherwise, you could just kind of go months without even seeing it and not being aware that someone's interested in your name. So those are two of the biggest ones I want to add. Then things like subdomain management, so you can create subdomains for any name that you buy currently. There's no functionality to do that within my app. I'll obviously add that. Reverse lookup in configurations. So if you've got an Ethereum address and you want to see what name is linked to that address, that's the reverse lookup, which I still need to add. And then I still haven't finalized the design. I designed everything, so I'm not a UI guy, so that needs a bit of an update. So that's kind of what my roadmap looks like to getting this thing done. So still a fair amount of work, but it's a usable product at the moment. Alrighty, so that brings me to the end of my presentation. Are there any other questions? Yes.
So I'm new to all this. So I was wondering, how do you deploy an application if you have multiple versions running?
Yeah. So that's something interesting about any contract that gets deployed to the blockchain, because you can't, once it's deployed, you can't go back and change it. Once it's deployed, it's done. For mine, obviously when I was learning, I had multiple deployments because I missed something and there's small little bugs, so I have to redeploy everything again. There are ways around that you can make kind of your quite a few variables inside your code to kind of handle those sort of things, but that gets quite complex. The deployment process itself is pretty easy. There is a framework called Truffle which I didn't use for this, but it does make deployments really easy to the chain, and just supply the right amount of gas and get dual thing deployed. So, yeah.